Start off with a first build log on the 11-foot long 1/75th scale Tirpitz. Most of this is 3D printed. At this point, you're seeing about 6 months worth of progress between design time and assembly and print time and all that. I printed off something like 50 sections, glued them together with super glue, and then added a layer of fiberglass on the outside of the hull. Lots of sanding and putty, and we get to this point. It's getting fairly close, but still quite a bit of work to do. By the time I'm done, I'd like the whole Battleship to look this good, this amount of detail. I'll make more videos on that as I'm painting the rest of the ship and show how I'm doing everything. I want to have these turrets move with some stepper motors, have some servo motors to actually move the barrels up and down, so I want to have really good functionality on everything. I have a couple of these magnet hatches for ease of access to different parts of the ship. Just last weekend, I was able to do the first powered float test of this thing. Still getting a couple of small little leaks that I'll have to patch up, but for the most part, working pretty well. This is the power pack. I have two 6-horsepower motors running this thing. It's definitely way overkill, but yeah, two 6-horsepower motors that are water-cooled ESCs, and that all just goes into this tank. But yeah, it has a lot of power. It can even haul a person in a kayak. It's that powerful. One of the issues that I found on the first test drive is the shaft came loose. Not really the best, especially because I don't actually have rudders on this right now. Well, I have rudders, they're just tied off. They don't really do anything. I'll be adding some servos to make those actuate eventually, but for right now, I'm just using differential thrust from the two motors to actually steer this thing. So losing a shaft is kind of a bad thing, but seems like it's just an issue with how I manufactured those. I basically took a Dremel to it to put a flat spot on them and put a set screw in. So I'm just gonna update my manufacturing technique for that, and I'll show you guys that when we get there. To fix it. You can see a bunch of sand in there. That's just from using sandbags for ballast. Kind of not the best when we have drive shafts right next to sand, so I have some changes in mind to fix that. The main update I want to make for ballasting is actually have water tanks built into the ship that I fill up with a water pump, so that I don't have to carry around like bags of sand or whatever to ballast this thing. I just basically set it in the water, flip a switch on my transmitter, and then it'll fill up with ballast and sit down in the water. Because this takes roughly 150 pounds of ballast to sit in the water far enough. It's a pretty big ship. 11-foot long, 18 inches wide. It's pretty big. Another thing I learned, I get the camera oriented here. Another thing I learned from the test run is these PLA props that I made are really not the best. When it hits some rocks or whatever, they kind of fall apart. So I'm going to be printing some new glass fiber nylon propellers. So got a big spool of glass fiber nylon, and I'm going to get that started here in just a sec. So here's that glass fiber nylon. I have a pretty crazy setup to hold it with these jack stands. But take what you got. And then I got the propeller printing right now, so we'll see that when it comes out. Well, that surface finish is not very great. I think there's still a lot of moisture in the glass fiber filament, but I'll see if I can fix that with just a little bit of sanding. So I wasn't able to get the glass fiber filament to work. I'll have to mess around with the settings a bit more and probably dry it out a bit more, but printed the propellers in ABS. Should be plenty strong, so good enough for now. We'll figure out that glass fiber stuff later. Another piece I've been working on, I got these here printed to cover the drive shafts in the hull. This bottom side matches the contour of the hull, and I'll just stick a bunch of super glue on it, glue it to the inside of the hull, and then I have this cover that's in 2 pieces that I'm gluing together, and that will seal up the drive shaft and keep grease from getting everywhere and keep sand and debris and stuff like that out of the U-joints. So I'll put that together in just a sec here. So those covers actually turned out really nice. I just have magnets on them, and they just pop in here, snap on, and that leaves it totally covered. See how nice that is. Then I don't get grease everywhere, and I don't get sand and stuff like that in the U-joints, so big improvement there. Now to show you a little bit about what goes into making a part. So this is just a little anchor point for zip ties. I'll show you kind of the whole CAD process here. Basically I start off with simple shapes. I have an idea in my mind of what I want to get to, and I just, make extrudes and make cuts and fillets and whatnot until I get to what I'm envisioning. Now for a bit of cable management, just gonna run some super glue on this area here, then just stick it all the places I need and slot a zip tie through there. As you can see, the cable management cleaned things up nicely. Got the battery wires going up sort of this direction, and I'll have them come up into the superstructure, and I'll have a little bit of a battery box in there. I also have these wires going over to the receiver. I'm going to try and mount the receiver up basically as high as I can on this ship, just so I have good connection to my transmitter. But yeah, that's about it. I'll play some video of this out on the water. It's a bit grainy just because it's getting pretty dark out, but I'll let you see that here in just a sec.